everyone. Hope you're not too tired today from staying up late last night. We're going to get started on chapter 13 today. Chapter 13 is all about costs, which end up being super important for economics. So this is going to be a chapter that's super important for you to understand. I'm going to split it apart into two different kind of lectures. So today is part 1 of chapter 13. And the name of the chapter is The Cost of Production. Okay, so the first thing is why do we care about costs in economics? The reason we care about costs is because if we put ourselves in the shoes of a producer or a manufacturer, the goal of that producer or manufacturer or firm is going to be to maximize their profit. So we typically abbreviate profit using PI. So the goal of a firm is going to be to maximize profit, and profit is equal to total revenue minus total cost, TC. Okay, so we've already talked really briefly in this class about what total revenue is. So total revenue is just the price of a good that's being sold times the number of units that are sold, so it's the price times the quantity. And total costs are subtracted out of the total revenue to figure out profit. So if a firm is trying to maximize their profit, then they really need to know what the total costs are and also how revenue is affected by costs. Okay, nested inside total costs are going to be kind of two flavors of costs. So there's going to be something called an explicit cost. Okay, what are explicit costs? These are things that require a monetary outlay. So most costs that you think of are explicit costs. So if you're a baker and you need to go to the grocery store and buy flour, that's an explicit cost because you have to hand over $3 in order to get your bag of flour. So by and large, the majority of costs are explicit costs. But there's also going to be, nested inside of total costs, implicit costs. Okay, what are implicit costs? Okay, explicit costs are things that require a monetary outlay. The implicit costs are going to be things that do not require a monetary outlay. Okay, so this is a little bit weird to think about. But the idea is implicit costs are basically opportunity costs. So anytime a firm decides to do anything, they're implicitly deciding not to do something else, and there's a cost not to do that something else. So for example, if I am a business owner and I take the money in my bank and I go out and I invest it in some property, well, what I'm giving up is the interest that I would have gotten on that money if I had saved the money and kept it in the bank. So that foregone interest is an implicit cost. Like a firm needs to take that into account, that by making a particular decision, they're giving up the opportunity to make money elsewhere, for example, getting interest. And so those are implicit costs that an economist cares about. Okay, so implicit costs are all opportunity costs. So again, an opportunity cost is whatever you're giving up because you're doing what you're doing. That's the opportunity that is costing you. And what's important for you to know is that economists, when we're thinking about profits, economists care about implicit costs. Accountants do not care about implicit costs because accountants, they're merely trying to track the dollars. And so implicit costs are the costs of things that weren't actually done. And so because they weren't actually done, an accountant wouldn't include implicit costs in their calculating profit, but an economist would, because an economist is trying to think about all the opportunities that's available to a manufacturer and kind of what is the cost of choosing this path as opposed to another path. So for your notes, accountants don't consider implicit costs, but economists do. Okay, think about how this would lead to kind of a deviation in the profit that an accountant calculates versus the profit that an economist calculates. If profit, I'm going to erase a little bit here, if profit is total revenue minus total costs, and one discipline has two things within total cost, and the other discipline has one thing within total costs, then an accountant would say profit equals total revenue minus explicit costs. So this would be accounting profit. An economist would say profit is total revenue minus explicit costs minus implicit costs. And so what's generally the case is that accounting profit is larger than economic profit because economic profit is subtracting something else out of the profit that accounting profit isn't. So what you need to know, I'll put three dots, this is a therefore. Accounting profit is generally bigger than economic profit. Okay, so this is just kind of conceptual things to be aware of. So now let's turn to the numbers and think about how you would actually start measuring different types of costs. Okay, the first kind of tool we're going to use when we're thinking about costs is something called a production function. Okay, what is a production function? A production function is, first of all, it's a function. So what is a function mathematically? A function represents relationships between different variables. And so what a production function is going to do is it's going to look at how a firm produces things, like its production, but it's going to turn its production into a mathematical kind of equation that says these are the things that impact how much is produced. So, so technically, the production function shows the relationship between the number of inputs used to make a good and the amount of good that is made. So it shows the relationship between the number of inputs that are used to make or produce a good and the number or quantity of goods that are produced. Okay, one thing I'm going to note, this is just a characteristic of production functions that will make sense once you see it, but I just want to make sure you have it in your notes. So one characteristic about production functions is if you plot them in a picture format. So if you have along the horizontal axis the number of inputs, and if you have along the vertical axis the number of goods that are produced, then what is true is that the production function is going to get flatter as production rises. So gets flatter as production rises. Okay, so let me kind of unpack this a little bit for you. Okay, so because a production function shows a relationship between the number of inputs, so this is like an independent variable, and the quantity of goods that are produced, or production, This will be the independent variable in a production function. This will be the dependent variable. And so graphically, when we're thinking about relationships between variables, we usually plot dependent variables, vertical axis, against independent variables, horizontal axis. Okay, so what that would give us is a graph that has on the vertical axis, so this is going to be a picture of a production function, the outputs. So if we're thinking about a firm that's making widgets, the vertical axis would just measure like the number of widgets that are produced. So for example, number of widgets. And then the horizontal axis is going to be the independent variable, which is inputs, like the number of ingredients that are used to make the output. So one input that is very important in economics is workers. So labor is an input. So an example of input might be number of workers. Okay, what we said is that a production function gets flatter as production rises. So what that means is when we plot the relationship between inputs and outputs, the line, or specifically the curve that we get, is going to be concave because it needs to get flatter. Okay, so production functions look something like this. Okay, what does this mean? Okay, curves are just a series of different coordinates. So there's just dots everywhere along this line. Each dot coincides with a particular combination of inputs and outputs. And the curve gets flatter and flatter. So for example, there's one dot down here. What does that mean? That means if you have 0 workers, you get 0 widgets. There's one coordinate right here. What does that mean? That means if you hire 1 worker, maybe you get 10 widgets. There's another coordinate here. What does that mean? Maybe it means if you hire 2 workers, you get 16 widgets. And then there's maybe another dot out here. If you hire 11 workers, you get 25 widgets. I'm making up the numbers. Okay, let's think about why this curve is characterized by concavity. So why does it get flatter as production rises? The intuition is the more inputs you have, the more you kind of run into this problem of too many cooks in the kitchen. So suppose we're thinking of a factory where they're making widgets and you need workers in the factory to produce the widgets. Well, if the firm goes from having 0 workers in that factory building to having 1, their output increases a lot. If they hire the second worker, their output still goes up, but it doesn't go up by as much as it originally did. Why? Because now the 2 workers kind of have to figure out how to work together, and that's not always a seamless process. And so you kind of get more bang for your buck out of the first worker than what you get from the second worker. Okay, if the firm just keeps on hiring, well, suppose the factory's kind of small and they have 10 workers packed into the factory making widgets, and the 10 workers are maybe making 24 widgets. Well, if they hire an 11th worker, the factory's already kind of jam-packed with workers. You bring in another guy, and it gets extra chaotic. The guys are kind of running into each other. So maybe by hiring the extra worker, production goes up by a little bit, but you get very little return from that extra worker because the extra worker adds some productivity, but he also adds more complication to the workers trying to figure out how to logistically work with each other and get the job done. So because of that, the production function gets flatter, it's concave. And again, what this means is that each additional input that's used to make the output generates fewer additional outputs than the input or the worker before it. Okay, so that brings me to the second topic. So the second topic is marginal product. Okay, marginal product is related to the production function. little bit of English. So marginal always refers to kind of like an incremental change. So if we're thinking about marginal product, it's like the incremental change in the product, which is measuring production. So the idea here is marginal product is if you hire one more worker. So we go from having a labor force of 10 people in the factory to 11 people in the factory. That's a marginal increase in one worker. If we want to know the marginal product, then we want to know for that extra one worker that was hired, the 11th worker, how much does he kind of add to the productivity? Okay, so in words, what the marginal product is it is the increase in output that arises from one additional unit of input. Okay, let's write, and then I'll show you how this kind of looks. So marginal product is the increase in output, which in our example was like the increase in widget production, that arises from one additional unit of input being used. So in our example, the inputs were workers, so it would be like an increase in the number of widgets that are produced, which occurs when there's one additional worker that's used to make the widgets in the factory. Okay, importantly, the marginal product is equivalent to the slope of the production function. So it's equivalent to the slope of the production function. Okay, let's think about why this is the case. Suppose we've got a baker. So his output is going to be like the quantity of cookies that his company bakes. And let's suppose the input is the number of bakers. Okay, the production function might tell us that if you have 0 bakers, you get 0 cookies. If you have 1 baker, maybe he can bake a dozen cookies, 12. If you have 2 bakers, maybe together they can make 20 cookies. If you have 3 bakers, maybe together they can make 25 cookies. So you would have coordinates like this. And note this is concave. Okay, what we know for marginal product is that the slope of the production function is equal to the marginal product. Okay, think about what the slope is. The slope is just rise over run. So if we want to know the marginal product of the first worker, well, just off the bat, we can just know that it's 12 because this one worker produced 12 cookies. So when we go from 0 workers to 1 worker, which is us using 1 additional unit of input, 1 worker, output goes up by 12. This says that needs to be equivalent to the slope. So if you go from 0 to 1, so if you go from this dot to this dot, you are rising 12 and you're running 1. So the slope of this little segment is 12. So that means right here, the marginal product, in this case, the marginal product of labor, is equal to 12. Okay, what about the marginal product of the second worker? Well, if you go from 1 baker to 2 bakers, this is a 1 unit increase in input. So we have 1 additional worker that's being used. The 1 additional worker, he increases the output from 12 to 20. So this second guy, really, he's contributing 8 cookies. So what that means is the marginal product is 8. That means that should also be equivalent to the slope. So if you go from this dot to this dot, you're rising 8, you're running 1. So the slope of that little section gives us a marginal product of labor that's equal to 8. and you can do the same thing for this segment. So the idea is the additional output that you get when you use one more input is a marginal product, and then that marginal product is going to align with the slope of the production function at the particular portion of the production function that you're looking at. So if you're looking at an increase in labor from 0 to 1, then this segment of the production function is going to have a slope that's equal to the marginal product of the first worker. If you're looking at increasing inputs from 2 to 3, then this segment of the production function is going to have a slope that's going to be equal to the marginal product of the third worker. Okay, one thing that you need to note is that because the production function gets flatter and flatter and flatter, and in other words, the slope is getting smaller and smaller and smaller, the marginal product is getting smaller and smaller and smaller. So we have a name for this, and we call it, very uncreatively, diminishing marginal product. Okay, and actually I'll erase and write it here at the top. So diminishing marginal product is simply a phenomenon in which the marginal product of the inputs that you're using diminishes the more and more inputs that you use. So diminishing marginal product is, again, it's simply a phenomenon. So it's a phenomenon whereby marginal product of an input, so in our case the input was worker, so we were calculating marginal product of labor, declines as the number of inputs increases. Okay, so again, just note this corresponds or is shown by the slope of the production function getting smaller, or in other words, getting flatter. Okay, so one thing that we get from this is, let's just think about what would be true about total cost if there is diminishing marginal product. So if there's diminishing marginal product, that means if a firm hires one more worker, then that last worker they hired is going to give them less increase in their production relative to the worker before them. So the bigger their labor market gets, like the less and less productive that last worker becomes. Okay, what that means is that total costs are going to kind of grow exponentially for the firm as they increase their output, because the idea is to increase your output, you need workers, you need inputs, but the latter workers or inputs that you're using are less productive than the original ones. You still have to pay them the same, so total costs are just going to get kind of bigger and bigger and bigger as the output of the firm increases, and that's all an artifact of diminishing marginal product. Okay, so for your notes, what you need to know is that diminishing marginal product, abbreviate this DMP, causes total costs to exponentially go up as more inputs are used. And as more inputs are used, output also goes up. So another way of saying this is diminishing marginal product causes total cost to exponentially go up as more inputs are used / output is, actually, let me restate this. Dimensional margin product causes total cost to exponentially go up as more output is produced. Sorry about that. Hopefully wrote in pencil, otherwise you can scratch like me. And the reason for that is because each additional input is kind of giving the firm less bang for their buck in terms of the amount it adds to the total production. Okay, so that's going to bring us to kind of the last concept of the day, which is the total cost curve. Okay, a total cost curve is pretty intuitive. The idea is we want to plot the relationship between outputs, this thing over here, and the firm's total costs. And when we do so, we get a curve. Okay, so the total cost curve is going to show the relationship between the number of units of output that are produced and total costs. So shows the relationship between the number of units of output produced and total costs. So this is going to be dependent variable total cost, and independent variable is going to be the units of output. So when you plot this, you're going to have along the vertical axis total costs, and along the horizontal axis you're going to have the output. So just note, when we're looking at production functions, output used to be up here in the vertical axis. When we're looking at total cost, output is going to be down along the horizontal axis. Okay, because of diminishing marginal product, what we had was that as output increases, total costs exponentially go up. So again, the idea is output is contingent on the number of workers we have, but each additional worker, which is needed to get more output, is kind of less productive as the worker before them. We have to pay them all the same, so total costs are going to kind of just sweep up as we want to grow the firm and make it larger. Okay, so an important thing to know about total cost curve is that it gets steeper as the amount of output rises. Okay, and you see this as, or you see this by the convexity of the total cost curve. Okay, I'm going to do a real quick side-by-side comparison of the curves we looked at today so you can just kind of make sure this is drilled into your minds, and then we'll break for the exercise. So we looked at two curves today, the production function and the total cost curve. So to summarize, there exists, backwards E, two curves. Today, we're going to add to this next class. Curve number one is a production function. Okay, the production function has along the vertical axis the output of the firm. So this is kind of like the quantity that they're producing, and it has along the horizontal axis the number of inputs. So this is kind of like the number of workers. And what we said is that this is going to have a slope that gets flatter and flatter to represent diminishing marginal product. The idea is as you hire more workers, each worker kind of contributes less than the guy before it. So if you hire one more worker, you get more output, but the more and more workers you hire, kind of the smaller vertical nudge that you get from that 1 unit increase in the input. And again, the slope of this is the marginal product of the input. The second curve that we looked at was the total cost curve. The total cost curve plots the total cost on the vertical axis against output on the horizontal axis. So note what used to be on the vertical axis for the production function is now on the horizontal axis for the total cost curve. And the total cost curve is going to have a slope that gets steeper and steeper. And this is going to represent the fact that as a firm wants to produce one more unit, its cost to do so is going to get higher and higher, and it's going to get higher at the increase is going to be more, the increase in total cost is going to be more extreme for the larger bases in the output that it's starting with. So if it's going from making nothing to 1, that's going to have a small increase in the total cost. If it's going from making 1 million units to 1 million plus 1 units, that 1 unit increase in the output is going to have like a pretty big increase in the total cost. And that's an artifact of the diminishing marginal product. Okay, so that's it for today. We're going to finish up the chapter next class. If you have questions about this in the next 2 minutes, let me know, and then after that we will meet back for the exercise. Okay, for the exercise today, I drew some pictures for you. Picture number one is a picture of a production function, and note what the axes are. So along the vertical axis, we have the output, so this is like the number of units that a manufacturer makes, and then along the horizontal axis, we have the number of inputs. So this would be like the number of workers that are used to make widgets. Okay, picture number two is a total cost curve. Again, note the axes. So the vertical axis is total cost, so this is the dollar amount, and then the horizontal axis is output. So what used to be on the vertical axis over here in the production function is moved over and it's positioned along the horizontal axis when we're looking at a total cost curve. Okay, so what I'm going to have you do for this exercise is complete a table where the numbers from the table coincide with the pictures. So in the first column of the table, we have inputs. So inputs are things that are used to make something. So workers are used to make output. And so the first column just has the number of workers. So a firm could hire 0 workers, 1 worker, 2 workers, 3 workers, 4 workers, 5 or 6 workers. The second column is a number of outputs that are generated by the inputs. So if a firm hires 0 workers, how many widgets are they going to make? 0. In this case, if they hire 1 worker, then they'll be able to produce 50 widgets. If they hire 2 workers, they'll be able to produce 90 widgets, and so forth. Okay, the first thing to note is that inputs and outputs are what we plot to generate the production function. So inputs are the values along the horizontal axis here. Number of units that are produced, outputs, are the numbers that are along the vertical axis here. Okay, the first thing that I would like you to do is I would like you to figure out the numbers that need to go in this next column. Okay, the next column is going to be measuring marginal product of labor. Okay, recall that this is kind of like how much output you get from the last worker that you hired. And it's also graphically equivalent to the slope of the production function. So I'm going to give you a couple of answers here and then let you calculate the rest. Okay, the first thing is we're going to kind of punt on the first row because if you have 0 workers, you can't reference it back to anything else. Okay, when we move down to the second row, if a firm goes from having 0 workers to 1 worker and their output increases from 0 to 50, then that means that that last worker that they hired, which was also the first worker that they hired, generated 50 additional units of output. Okay, how does this coincide with the slope of the production function? If you move from 0 to 1, then that is like you're running 1. And if you go from 0 workers to 1 workers, your output goes up from 0 to 50. So you're rising 50. So slope is rise over run, so we're rising 50, running 1. That's a slope. That's also the marginal product of labor. I'm going to do one more row for you and then let you complete it on your own. Okay, if a firm goes from having 1 worker to having 2 workers, there's been a 1-person increase in their labor force. Then when they hire the second worker, their output goes up from 50 to 90. So that last worker that they hired, the second guy, he generated them an additional 40 units. Okay, again, the marginal product is the slope of the production function. So when the firm went from having 1 worker to 2 workers, well, their inputs went up by 1, so this is how many units they're running. But when they go from 50 up to 90, they're rising 40. So again, slope is rise over run. We're rising 40, running 1. So the slope from this dot to this dot is 40, and that's our marginal product of labor. So what you need to do for the rest of this column is fill in numbers for the rest of the rows. So for the 3rd worker, 4th worker, 5th worker, and 6th worker. In terms of actually putting this into Blackboard, I know you can't really easily put in a table. Just put like commas between the numbers that go along with these rows. Okay, the next part of this is I have some more numbers in the table for you. So this next column is going to tell us how much the cost of a factory is. So suppose that it costs this company $30 to rent a factory, and you just pay rent no matter how much you're making in the factory. So if you're not making anything, rent's $30. If you're making 1 unit, rent's 30. If you're making 6 units, rent's still 30. Okay, so this is going to be a component of their cost. And then they're also going to have the cost of hiring the workers. So if they pay each worker $10, I'm just making up this number, if they pay them $10, then if they have 0 workers, the cost of workers is nothing. If they have 1 worker, their cost of workers is $10. If they have 2 workers and they hire each one of these and pay them each $10, then the total cost of workers is $20, and so forth. Okay, what you need to do now is fill in numbers for the total cost of the firm. Okay, if the firm has 0 workers, what is the total cost? Well, they've got to pay the $30 for the factory. They don't have to pay anything for the workers, so their total cost is $30. Now, note how this lines up with this picture. So the total cost curve plots against each other the total cost and the output. When the output is 0, which is what we've got on this first row, the total cost is 30, which is the number you just got. I'm going to do one more for you and then let you fill in the rest of the table. Okay, what would the total cost for the firm be if they have 1 worker that they hire? Well, if they hire 1 worker, they've got the $30 they have to pay for the factory. They have the $10 now that they have to pay for the worker, so their total cost is going to be $40. So now note how this lines up with the total cost curve. If they have, actually this is not super relevant for the total cost curve, this is relevant. If they have 50 units that they are producing, which is right here, then what is their total cost? It's $40. Sorry, I'm speaking before I'm thinking here. So the total cost curve plots against each other output, which is this column, and total cost, which is the column you're filling in. So when output is 0, total cost is 30. When output is 50, total cost is 40. And then you'll fill in the rest of the numbers. Those will just give you the coordinates that I've already plotted for you. So again, what you need to do to fill in this table is just find these numbers that complete the column, put a comma between the numbers, put that response into Blackboard, and that will be it. And then the pictures are a good way for you to just kind of verify that the numbers you're getting align with everything. That's all I have for you. Again, if you haven't read this chapter, make sure you go back and read it, and then we'll finish it up next class.